Myself, Pushpendu Chandra Chandra, PhD Research Scholars of Northeastern Regional Institute of Science and Technology. Today, my topic is effect of tool incline angle on microstructural and fractural characteristics of friction star welded pure copper bar joints. So these are the contents: are introduction, experimentation, result and discussion, conclusion, acknowledgement and reference. So friction star welding is a solid state welding method which was first created for the welding of aluminum alloys. In recent years, some work has been done to expand the method used to heavier materials including copper, composite material, steels, titanium alloys among many others. Friction star welding technique is based on the idea that when a particular amount of pressure is applied to the material of the workpiece, a non-consumable tool made of solder and peel rotate to generate frictional heat, which causes plastic deformation. Without attaining any its melting point, the rotating tool plasticizes the material as it moves along the joint line and physically combines the materials by steering. In the present study, the pure copper is used as a base metal. The dimension of copper plate are 100 mm long, 75 mm wide and 2 mm thickness. A 16 mm diameter tool made of tungsten carbide is used for the FSW welding. The table shows the process parameters where tool rotational speed, welding speed, tool offset and plunge depth are fixed at 750 rpm, 24 mm per minute, 0 mm and 0.2 mm. And variation of tool tilt angle or incline angles of 1 degree, 2 degree and 3 degree. After that, the samples for metallographic investigation were cut perpendicular to the direction of welding and they were polished using emery paper of a certain grade. After that, the polished samples were etched with 100 ml of H2O, 25 ml of HCl and 5 gram of FeCl3. The microstructural examination was done using optical microscope and scaling electron microscope. So, result and discussion. It is clear from the figure that the weld nugget zone contain much less uniax grains compared to the BM. It is observed that the grain formation at welded nugget zone are more refined and uniform during the welding at 2 degree tool tilt angle. So, this table represents the summary of grain size in weld nugget zone of the FSW pure copper and base metal. The average grain size of the base metal is 19.60 micron. The average grain size of 1 degree, 2 degree and 3 degree tool tilt angle are 5.218 micron, 3.484 micron and 7.12 micron. So these are the fractural morphology. From figure, it is clear that the modes of fracture are in ductile manner. The dimples are present in the all fracture surfaces. So this table represents the fracture characteristics and mechanism. For 1 degree and 2 degree tool tilt angle, the small dimples are present in the fracture surface and fracture mechanism are microvoid coalescences. And for 3 degree tool angle, the big dimples are present in the fracture surface and fracture mechanism is slipping. So these are the conclusion. The grain formation at the weld nugget zone are more refined and uniform during the welding at 2 degree tilt angle other than 1 degree and 3 degree. The average size of the weld nugget zone of specimens C1, C2 and C3 and BM are 5.218 micron, 3.484 micron, 7.112 micron and 19.60 micron. The fracture characteristics of specimen C1, C2, C3 are small dimples, smooth and small dimples, big dimples correspondingly. The fracture for weld specimen C3 is followed by slipping mechanism. However, the weld specimen of C1 and C2 are maintained with micropoid tolerances. So this is the acknowledgement. So finally, acknowledge the Northeastern Regional Institute of Science and Technology and the National Institute of Technical Teachers Training and Research for my present research work. So these are the reference